Hey guys, so Miss May misses you guys so much. She's going to rock the lesson for you today. So get ready to learn some new material. We're in chapter 11, so keep up the hard work.
Woo! All right, chapter 11. So today we're doing section 11.1, simplifying rational expressions. There's going to be a lot of factoring, so that's what the warm-up is. Here we have 3 terms, so I'm making my big X. My A times C goes on top, 1 times 18, 18. My middle term, 9 will go in there. 18, multiply to 18, add to 9. What are we thinking here? 6, positive 6 and positive 3. We divide by AX, which is just X. We turn them. So this factors to be X plus 6, X plus 3. Boom, factor, 3 terms. Here I only have 2 terms, so I'm thinking more GCF. Thinking what goes into both of these. A 2 can go into both 2 and 4, and I need to bring my lowest exponent, which is just X. I take that out by dividing it. So then I'm left with here, I'm left with just X. Here I'm left with negative 2. Don't forget, whenever you take this out, it needs to go in front. Boom, factored. So those are the 2 examples you're going to see a lot of today. So we're talking about rational expressions in chapter 11. It's a polynomial over a polynomial, similar to this example here, right? We have x minus 1 over x minus 5. This you can't do anything with, but 5x minus 5, I'm thinking a GCF. And I can take out a 5 from both of those. So I'm going to leave the top the same. On the bottom, I'm taking out a 5 from both. So, taking out a 5, I would be left with x here and a minus 1. Oh, check this out. We have an x minus 1 and an x minus 1. Boom, they cancel. But don't forget, I'm still left with a 1 on top and a 5 on the bottom. So that's what your answer for that situation looks like. So you factor when possible, cancel the common factors, and then now we're going to write what the excluded values are. So you want to look back on this step here before we cancel. You need to set the denominator, each of those things equal to 0. So I set 5 equal to 0, that's not going to give me anything. And I set x minus 1 equal to 0. I add the 1. So I get x equals 1, or it doesn't equal 1 here. So the bottom can't be 0 anywhere. Whoops. So I want to set each of my denominators equal to 0. So this would be my excluded value and my answer. So you have 2 answers every time, your excluded values and what it would simplify to be. All right, now we're going to work through some examples that you'll see kind of in the homework here.
Miss May, I have a question.
Yes.
Why is an excluded value? Why can't it be 1? What would happen if I said that x could equal 1?
Great question, Mr. Deshane. If x was 1 here, then I would get 1 minus 1 is 0. 5 times 0 is 0, so then I would get an issue here because I would be dividing by 0, which is not allowed. The denominator cannot equal 0.
Nice, thank you.
Yes. Okay, so again, our first step is we're looking to factor. There's nothing I can do with 1 term, so I'm going to leave the top the same. On the bottom, I have 2 terms, so I'm thinking GCF. I can take out between 4 and 8, I can take out a 4. So I take out a 4 here, and then I would be left with, if I divide by 4, I'd be left with just D. If I divide by 4, I'd be left with plus 2. Nothing I can do with the D plus 2. There's no D plus 2s over here. I can't cancel the D separately. Remember that. This is a group. These are stuck together. But I can cancel my 4 and 18. Between 4 and 18, 2 goes into both. So then I'll be left with 2 and a 9 here. That's all I can do from there. Again, I can't cancel these D's because this is a group added to the 2. So on the top, I still have a 9 and a D squared. And then on the bottom, I have a 2 and a D plus 2 still. Nothing more I can do from there, so that would be my final answer. Now we're doing those excluded values. Don't forget about that. I go before I canceled right here, and I'm setting each of my factors equal to 0. I get 4 doesn't equal 0, nothing I can do with that. And then I get D plus 2 cannot equal 0. I subtract the 2 to solve, and I get D cannot equal negative 2. Oops. So that would be my excluded values. All right, I'm going to give you guys a little bit of time to try out these 2 examples. Go ahead and write them in and give it a little practice.
Hey, Miss May, I have a quick question. On the last example, that 2, parenthesis, D plus 2, do I have to redistribute that back for my final answer?
No, you can leave it in or you could distribute. Both answers would be correct there.
Okay, thank you.
All right, moving on. Let's see how you guys did on these. These ones you can see will be a little bit different because we have 3 terms. So looking at the top, oh, I see that I can take out a GCF of 3 because 3 can go into both of those, and then I would be left with just an x and a plus 2 if I take a 3 out. On the bottom, I'm thinking x factor method here, multiplying to be 1 times -6, adding to be -1. I'm thinking -3 and a +2 would be good there. They would add to be -1, divide by x. And then I'm going to turn them to bring out my factors here. I get x minus 3, and I get x plus 2. Oh, hey, check it out, the fun part. Boom. Did I mess up? Whoop. 2x plus 2 is there.
Nice catch, Miss May.
Yes. So then I have a 3 on top and an x minus 3 on the bottom. Boom. Don't forget about your excluded values. Before you canceled, right here, we're going to set each of those not equal to 0. So I have x minus 3 is not equal to 0, and x plus 2 is not equal to 0. I solve. Here I would add the 3 over, so I get x does not equal 3. Here I would subtract the 2 over, so that I get x would not equal -2. So in this situation, I have 2 excluded values. And again, I need to write those because this would only be true if those were not equal, or those were not equal to 3 and -2 to cause the bottom to be 0 there.
Nice.
Any questions?
Yeah, Miss May, on the next one, if I can factor that in my head without the big X, can I just go ahead and do it without the big X?
I always think it's good to show work, but if you know how to factor it without the big X, that's fine with me.
All right.
All right, but I'm going to do the big X because I like the big X. Okay, here we go. These are both 3 terms, so I know I want to use the big X factor. Boop, 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 boop. All right, on the top I have 1 times -6. On the bottom I have a -1. Hey, I just did this one. That one was -3 and +2. Here I'm dividing by C. So I'm going to rewrite the top factored form. It became C minus 3 and C plus 2. Now I'm going to factor the bottom. Again, 3 terms. I'm thinking x factor. 1 times 6, and my middle term is 5. I'm thinking 6 and 1, but that would have to subtract, which I don't have a negative here, so I'm still 3 and 2, but they're both positive. Divide by C. So the bottom, this would factor to become C plus 3 and C plus 2. Oh, here we go. We see it. Boom, boom. Those are gone. They cancel each other out. Mr. Deshane, what do you think? Will my C's here cancel?
No, one's a C minus 3 and one's a C plus 3, and you said that if they're grouped together in a pair, can't do it.
Correcto. So that's just my answer. I'm left with a C minus 3 and a C plus 3.
Nice.
Again, I took the parentheses off there, but if you want to leave them on, that would be sufficient as well. Boom. All right, am I done?
What about your excluded values?
Oh, yes. Come back here. Before we knocked everything out, I have C plus 3 does not equal 0, and C plus 2 does not equal 0. I would subtract the 3. C does not equal -3, and C does not equal -2 by subtracting the 2 over. So in this case, again, I have 2 excluded values there. Whoops. There we go.
Nice.
All right. Feeling good?
Yeah.
On to the back. All right, there's a few type of tricks here. The problem here is this is in the wrong format, right? We want to get it into standard form. So if I were to rewrite it, it would be -x squared in front plus 4. I'm going to keep the bottom the same for now. Now this, we don't want to factor with a negative in front. So what we do is you pull out a -1. So if there's a negative on the x, you want to, or it looks backwards, you're going to pull out a -1. So if I pull out a -1, well, now this is going to be positive x squared. And then careful, this is going to change sign now because I'm dividing by a negative. And now that looks like something much better that I want to use. So now we're doing what we did on the front. We want to factor when possible or pull out a GCF by factoring. This one we haven't seen yet, but this is our special case. right? These are both perfect squares. So if I were to factor that one out, I would square root each. I have an x and an x. And then to get a 0 in the middle and a -4 would be a +2 and a -2. Again, you could do the x factor method there and think about what has to be 0, but this was a special case, so be careful about that on the homework. The bottom is a GCF case. I have two terms here. I can pull out a 7. And then if I pull out a 7, I'm left with x here and a -2 there. Oh, hey, do we see it?
Yeah, Miss May, x minus 2.
Boom! Knock them out. They're both the same thing. That's it. Nothing much I can do with the rest. So then I just rewrite my answer. I have a -1 on top and an x plus 2 here in parentheses over 7. So just as Mr. Deshane was suggesting before, you could distribute the negative in, but that's just a little bit more work and we're good with that answer right there. Nice. Don't forget! What are we forgetting?
Excluded values!
Don't forget. Okay, I'm going to do it over here because I have more room. Before I canceled, that was in this step, I would set 7 not equal to 0. That doesn't give me anything. And an x minus 2 not equal to 0. Add the 2, x does not equal 2.
Nice.
Again, every time I should have two answers. One for my solution by simplifying and factoring, and one for my excluded values. All right, take this time to try out that new trick on this example here. All right, again, this is in the wrong format. I want to turn it around. So I'm going to have a -n² in front and a +2n. Leave the bottom the same for now. This is where we want to use that -1 pull-out thing. So I pull out a -1, and then both of these are going to change signs. So I'm going to have a +n² and a -2n. Now we're thinking about the further factor. This here is not the special case like the last example. This one is we can pull out an n. So I'm going to pull out the GCF of n, and then we're going to multiply it to this -1, so it's going to become -n in front, because I'm pulling out an n and there's already a negative. If I pull out an n from n², it's just one n here, and if I pull out an n, I'm just left with -2. Here, between a 3n and a -6, I can pull out a 3, and then I'm going to have an n minus 2. There it is. I know I did it right because I'm canceling things.
Nice.
Boom, boom. So then I'm left with -n on top and just a 3 on the bottom. Cha-ching. Now we have to do our excluded values. Before I canceled, right here, I said each of those not equal to 0. Nothing going to give me with that. That's not telling me anything. And then here I add the 2 over, and is not equal to. Boom. There's my two answers. Simplified and my excluded values. Hopefully you guys got that all on your own.
Nice.
All right, here's the Mac Daddy word problem. We're going to power through this together. Try and follow the steps as I go along, and you will be successful on the homework. We can do it. All right. Suppose that a sphere with a radius of 4a has the same volume as a cone with a radius of 5a. What is the height of the cone? So we're going to be looking for h. Give your answer in terms of a. So just leave a in there. We're just going to move everything around. So here's our formulas. V is that. That's for our sphere. And V is this for our cone. So we're thinking they've given us the radiuses, so we're going to plug that in for our R values. There's two separate ones, so I'm going to do them just side by side for now. My first one, for my sphere, volume equals 4/3 pi. And I'm plugging in my R. Put it in parentheses because there's two things to a power. So that was my first one. Now I'm going to do my second one. Volume is 1/3 pi R². I got to plug in my R, 5a. And then I'm leaving h. All right, let's simplify these down. V equals 4/3 pi. Here I need to bring the 3 to both things here. I'm going to get times 4 to the 3rd, 64, a to the 3rd. So don't forget you need to cube both the 4 and the a. All right, from there I'm going to do this guy, 1/3 pi, distributing my 2 to both. So I get 25 and an a², and then just leave that h on the end. Okay, I'm going to do it. You can do it a little bit different by simplifying these down, but I'm just going to start setting them equal to each other. So we're trying to figure out when their volume is the same. So the v and the v are the same. So I'm just going to replace this v with this equation. So I have 4/3 pi, I have a 64 a to the third, equal to 1/3 pi times 25 a squared h. Doesn't that look great? Have fun. Yes. Okay, we're trying to solve here for h. So what we need to do is get rid of all of these things here. So what I'm going to do, because these are multiplied, is divide. So I'm going to divide all of this to both sides to get h alone. So I'm dividing by 1/3 pi 25 a squared, 1/3 pi 25 a squared. Whew. So then I just have h over here.
Nice.
Now all we got to do is deal with this mess on the left. So there's different ways you can simplify. If you're feeling confident with your calculator, you can just put these numbers into the calculator. But here we go. Some easy things. Pi's cancel. Dividing by 3 cancels. 25 and 64, nothing goes in there. So let's see what we got so far. I have a 4 still. I have a 64. Oh, look at this. I have an a to the third over an a squared. I subtract my exponents and I just have an a. And then on the bottom, what do I have? I have a 1, which I don't really care about, and a 25. Woo! We're getting there.
Closer.
Last step. I just got to combine these on top. I don't know. What is 64 times 4? Any guesses, Mr. Deshane?
256.
Hey! 256. Still have an A and a 25. Woo! We did it!
Dang, Miss
I know
May.
it's a challenging one, but you guys can do it. Follow the steps.
Miss May, is that going to probably be on the homework?
Oh, yeah.
And if I am struggling, will you have office hours this week?
Yes.
Okay.
I'm always available. Mr. Deshane is always available. Feel free to set up a time to meet and go over problems.
Awesome. You rock, Miss May. Thank you.
You rock.